Hello guys, we'll start with the numericals which are based on regression chapter. So let us go to exercise 27, okay, of your textbook. And in exercise 27, let's go to question number 9. Let us understand what is given in the problem first of all. So summation x is 24, which is given in the problem. Summation y, that is equal to 44. Summation x into y, 306. Summation x square, 164. Summation y square, this is equal to 574, and n is equal to 4. Okay, this data is given. First we'll calculate x bar and y bar. Summation x upon n. In statistics, always try to calculate x bar and y bar first. So 24 upon 4, which is 6, and this is 44 upon 4, which is 11. Okay, now if you read the problem, you are supposed to find out regression coefficient of y on x. So regression coefficient of y on x is nothing but byx. This is what is asked. Okay, so byx is nothing but covariance between x and y upon standard deviation of x square. Equation number 1, covariance of xy. Okay, I'll use this formula because summation xy is given in the problem. Summation xy is given to you in the problem. Okay, so summation xy is 306 upon n is 4, 6 into 11. Okay, now see guys, for covariance and variance, okay, don't get the answers in decimal. Keep it in fraction, reduced fraction. Okay, so this is 153 upon 2 minus 66. So 153 minus 132 upon 2. I have reduced this. Okay, right? So it was not divisible, right? So I just reduced it. I hope everybody understood this. Minus 66. So take LCM over here. 2 into 66. 132, and 153 minus 132 will give you 21. 21 upon 2. So as I said, you covariance, variance, do not keep it in decimal. Keep it in reduced fraction. Then we are supposed to calculate standard deviation of x square. Okay, so whenever you are supposed to calculate standard deviation, first calculate variance. So variance of x, we'll use this formula, summation x square upon n minus x bar square, right? So summation x square is 164 upon 4 minus x bar. X bar we have calculated earlier, that is equal to 6. So this will be minus 6 square. So 41 minus 36, which is equal to 5. This is variance of x. Now variance itself is standard deviation square. Variance itself is standard deviation square. Okay, so we got standard deviation of x square. Now from 1, we have marked equation number 1. I'll take you back to that particular equation. We have calculated both the things. So byx is equal to, put the respective values, 21 upon 2 divided by 5. So 21 upon 2 into 1 upon 5, 21 upon 10, which is equal to 2.1. That is the value of byx. Okay, let's take the next problem. Question number 10. Summation x is given as 125. Summation y is given as 100. Summation x square. Summation x square is 1650. Summation y square. Summation y square is 1500. Summation xy. Summation xy is 50. N is equal to 25. Okay, so this piece of information is given to you. They are asking you two things. First, they are asking you to calculate line x on y, and secondly, they are asking you to calculate x when y is equal to 5. Okay, so first and foremost, we are going to calculate x bar and y bar like the previous problem. So summation x, that is 125 upon 25, which is 5. Y bar is equal to summation y upon n. Summation y, that is 100 upon 25, which is equal to 4. X bar and y bar we have got over here. Okay. Now line x on y. Line x on y. X minus x bar bxy, y minus y bar. Okay. So this is your line. Let it be equation number 1. Now regression coefficient of x on y, that is bxy, is equal to covariance of xy upon standard deviation of y square. Equation number 2. Fine. First, we'll calculate covariance of xy. Looking at the data, we have to decide the formula that we are supposed to use. So summation xy. Summation xy given in the problem is 50 upon 25 minus x bar into y bar. So luckily x bar and y bar are integers. If they are decimal numbers, I would insist don't take decimal numbers right at the beginning. Keep it in fraction. This we do because we want more accuracy in the problems while solving the problems. So this is 5 into 4. Okay. So this will be 2 minus 20, which is equal to negative 18. So we got the value of covariance of xy. Now standard deviation of y square. While calculating standard deviation of y square, we'll first calculate variance of y. So variance of y is equal to summation y square upon n minus y bar square. So y square, what is y square? Y square is 1500 upon 25 minus y bar. Y bar is 4. So this will be 4 square. See, y bar is 4, right? So 1500 divided by 25. Answer is 60 minus 16. That is equal to 44. This is variance of y, which itself is standard deviation of y square, 44. So from equation number 2, bxy. So the covariance value is minus 18 and standard deviation square is 44. Minus 18 upon 44, which is minus 9 by 22. Don't divide this. It will be a waste of time. Keep it as it is in a reduced fraction. So from 1, bxy is the regression coefficient of x on y. And line y on x will get from equation number 1, x minus x bar bxy minus 9 by 22, if I'm not wrong. Yeah, y minus y bar. Y bar is 4 over here. So cross multiply. minus 9y minus 4. 22 I have taken on the other side. So 22x minus 110 minus 9y plus 36. So 22x is equal to minus 9y, 110 plus 36. That will be plus 146. So this is your line x on y. Okay, first part of the problem is over. We'll go to the estimation now. Okay, so basically this we have done. We'll calculate the value of x when y is equal to 5. So x is required when y is equal to 5. So x depends on y. Use line x on y. And x on y line we have already calculated, which is 22x is equal to minus 9y plus 146. Now in this, put the value of y as 5, put the value of y as 5, which we have done. So 22x is equal to 146 minus 45, right? Which is equal to 101, and x is equal to 101 upon 22. Now this is the estimation. So now for the final answer, you can just divide this. 101 divided by 22. So the answer is 4.59. Okay. Keep it up to 2 decimal digits, right? So that was your question number 10. In the same exercise, let us proceed with question number 18. Okay. So find the regression coefficients byx and bxy. Byx and bxy, these are the regression coefficients which are required in the problem, right? Standard deviation of x and y are 4 and 3 respectively. So standard deviation of x is equal to 4, standard deviation of y is equal to 3. Okay, we need to, they also have given correlation coefficient, that is r. R is equal to 0.8. Fine. So now first of all, byx is equal to r sigma y upon sigma x. I am not using covariance formula because r is given in the problem. So whenever r is given, use r formula. So r is equal to 0.8, which is 8 into 8 upon 10. Standard deviation of y, which is 3. Standard deviation of x, which is 4. So 4 ones are 4 twos are, and this is 6 upon 10, 0.6. That is the value of byx. Okay, bxy. R sigma x upon sigma y. R is 8 upon 10. Standard deviation of x is 4. Standard deviation of y is 3. Put the respective values. Okay. Right. So this will be 32 upon 30. Right. So we have to solve this. 32 divided by 30, which will give you 1.066666. So we can write it up to 2 decimal digits, which is 1.07. This is your question number 18, right? Let us proceed with question number 19 of the same exercise. R is equal to 0.6, which is given in the problem, correlation coefficient. Variance of x is equal to 225. Therefore, standard deviation of x is equal to root of variance of x. Root of 225, which is equal to 15. Variance of y is equal to 400. Therefore, standard deviation of y is equal to root of variance of y, root of 400, which is equal to 20. Okay. Now they are asking both the regression lines. So before calculation of regression lines, I'll just calculate what is byx and bxy. Okay, regression coefficients I will calculate. So byx, r sigma y upon sigma x. So r is 0.6, which is 6 upon 10. Standard deviation of y is 20, and this is 15. Standard deviation of x. So if you solve this, okay, so you'll get byx as 0.8, which is 8 upon 10, 4 by 5. I would prefer keeping this in reduced fraction. Bxy, r sigma x upon sigma y, 6 upon 10, r is given as 0.6, so this is 6 upon 10, 15 upon 20. So if you solve this, okay, so the answer that you will get is 0.45, which is equal to 9 upon 20, right? Reduced fraction. So the regression coefficients are in place. Fine. So what I will do is, first I'll calculate line y on x, y minus y bar, byx, x minus x bar. Okay. So mean of x is 10. That's given in the problem. Okay. So x bar is equal to 10, and mean of y bar is equal to 20. This is also given, right? Okay. So let's substitute these values. Y minus 20 byx is equal to, if I'm not wrong, it is 4 upon 5, which we calculated. Okay, x minus x bar is 10, so 5 into y minus 20, 4 into x minus 10. So 5y minus 100, 4x minus 40, 5y is equal to 4x, plus this 100 will move on the right hand side, 100 minus 40, that is equal to 60. This is your line y on x. Okay, this is line y on x. Line x on y, x minus x bar equal to bxy, y minus y bar. So the x bar value is 10, bxy is 9 by 20, which we calculated some time back. Okay, y minus y bar is 20, given in the problem. So 20 into x minus 10, 9 into y minus 20, 20x minus 200 is equal to 9y minus 180. 20x is equal to 9y. 200 minus 180, that is plus 20. And this is line x on y. This is line x on y. Okay. So these two lines were asked in the problem, and we have solved it as per the requirement. Let us go to question number 21. Carl Pearson's correlation coefficient is given in the problem, which is 0.28. R is equal to 0.28. Covariance COV of xy is equal to 7.6. Variance of x is 9. Therefore, standard deviation of x is equal to root of variance of x, root of 9, which is equal to 3. Fine. They're asking you standard deviation of y. This is what is asked. Now, this problem basically is from the first year of ISC syllabus. What we'll do is we'll use this formula. R is equal to COV of xy upon standard deviation of x, standard deviation of y. R is 0.28, which is 28 upon 100. Covariance is 7.6. Then standard deviation of x. Standard deviation of x is 3, and then we have standard deviation of y. Okay, so this will be 28 into 3 into standard deviation of y is equal to 7.6 into 100. Okay, so 28 into 3, if you multiply, you'll get 84. 84 into standard deviation of y is equal to 760, right? Just a second. So standard deviation of y is equal to 760 divided by 84. So if you divide this, you'll get something as 9.0476. So we can write this as 9.05. Rounded up to 2 decimal digits. That's your answer. Okay. Let's go to question number 22. Fine. So x bar is equal to 6, y bar is equal to 8. That's given in the problem, mean of x and y. Standard deviation of x is equal to 4. Standard deviation of y is equal to 12. Again, this piece of information is given in the problem. R is equal to 2 by 3. Fine. First, we are supposed to calculate byx and bxy and the two lines. Okay. So byx, r sigma y upon sigma x. R is 2 by 3. Standard deviation of y is 12. Standard deviation of x is 4. Okay. So the answer is 2 over here. Bxy, r sigma x upon sigma y, 2 by 3 into 4 by 12. Okay. So this will be 4 ones are 4 threes are, and this will be 2 by 9. So the two regression coefficients we have calculated. Now we will find out the lines. So line y on x, y minus y bar, byx, x minus x bar. So y bar is nothing but 8, byx is 2. If I'm not wrong, yes. So byx is equal to 2, x minus x bar is equal to 6. So y minus 8, 2x minus 12, y is equal to 2x minus 12 plus 8. So 2x minus 4. So this is your line y on x. Fine. Line x on y. X minus x bar, bxy, y minus y bar. X bar is equal to 6, bxy, 2 by 9, y minus y bar. Y bar is equal to 8. Cross multiply this. So 9x minus 54, 2y minus 16. 9x is equal to 2y, 54 minus 16. That will give you plus 38. This is your line x on y. Fine. So the two lines are ready with us. They're asking you what is the value of y when x is equal to 10. Y depends on x. Use line y on x. So the line y on x is this. 5y is equal to, just a second. This is line y on x. Y is equal to 2x minus 4. Okay. Put the value of x as 10. Right? So if you solve this, the value of y is equal to 16, right? Okay. So these were a few numericals to start with the chapter. In the next session, I'll be taking up some more numericals based on the chapter of regression. Okay, thank you.